Good afternoon, everyone. My name is Bailey Hepler, and today we're going to be looking at my protein synthesis project. We have here, the good old process for protein synthesis, but then we also have here kind of like a real-world example, like for people that kind of just work office jobs. If you've ever done one of those, they kind of suck. But basically what we got going on over here is we have protein synthesis right at its beginning process. Basically what happens is we have DNA, our deoxyribonucleic acid, wow. But then we have that going here to the polymerase, which is this giant like copying machine. But right before it gets in there, it can't just like slide in there just like a freaking, it just can't go in there all twisted up. It needs to be split apart. And when that happens the way that happens is from this little transcription factor right here. That guy binds to the DNA and starts just unwinding it and making it like able to actually, be copied. And so what this polymerase does is it starts making the copy. And what we get is we get a pre-mRNA, which basically has all these little introns and exons. Basically, introns are basically things you don't really need for this whole protein process. I mean, it's still useful information, but it's not what's needed. Exons are what you need. And so the cell and all that makes this happen. It gives you only the exons, and then when that's done and completed, the process goes out of these nuclear pores. That kind of really look kind of weird, not gonna lie. But then we get to the next process where we meet the good old friend called the tRNA. And what he does is once we get to the mRNA, it goes into this nice little buddy boy called a ribosome. And what a ribosome does is it starts putting the tRNA and putting together with the mRNA, but just to combine amino acids. It's the main point of it. It just does that. And once these amino acids start making peptides, or in this case, a polypeptide, it starts making a giant chain, which honestly, the amino acids just look like a bunch of beans. And it's super weird to just imagine that as a bunch of beans on a string. But once it goes from that, it goes to a bigger string, completed string. And then once we get to the completed string, what starts happening is that string starts folding up and making a shape. And once it starts to make this shape, it eventually either becomes a helix or a little like plated sheath, like a giant list, just imagine a curtain and you'll be fine. Once it gets to that, then these things start to go into these little things, which are basically like smaller versions of this. And then those things start to just completely combine up to where you have these. These are your modified functional proteins. And those are the finished product of what you need from all this. Next, we're gonna move on to my little example here. We have, basically the process of getting it all printed, splitting everything up, which kind of happens right here. But like I said, this isn't an exact process similarity. It's just something that's similar in real life because you don't really see things being just split apart, taken apart, then put together, and then those pieces doing that in a whole bunch of normal day-to-day processes. And so this is the one thing that I can really kind of say. Okay, moving on. Then we have this, and it's basically removing the little excess BS, like the exons and introns stuff. Then we get to the basically the port where we just need kind of these buddy boys, the amino acids, instead of just the full mRNA and all that junk. Then we have the finished product.